Part 1: When the Universe Hides Giants. Since the dawn of modern astronomy, one theory has remained foundational. Every large galaxy hosts a supermassive black hole at its center. This wasn't some random guess. Observations from the Milky Way to other colossal galaxies across the cosmos supported this idea. These black holes aren't just light-swallowing pits, they are the beating hearts that orchestrate the movement of billions of stars. The universe, with all its cold and harsh laws, contains an immense rhythm at the heart of every galaxy. But then came a galaxy that froze scientists in their tracks. Messier 83, also known as the Southern Pinwheel Galaxy, 15 million light-years away, a beautifully spiraled galaxy aglow with stars and gas. The problem? It showed no clear signs of hosting a supermassive black hole at its center. No X-ray jets. No gamma-ray bursts. No blazing accretion disk. A complete and utter void where there should have been a blazing inferno swallowing everything in sight. Astronomers labeled it a truly strange anomaly. Why doesn't M83 have a black hole, or is it simply hiding very well? James Webb, Unmasking the Shadows. The answer may lie in a new tool, the James Webb Space Telescope JWST, the most sophisticated infrared eye humankind has ever launched. And like Hubble, which peers at the universe through visible light, Webb sees in infrared, allowing it to peer through thick curtains of cosmic dust that once obscured our view. When scientists pointed JWST at Messier 83, they didn't expect to see much. This gas only forms under the influence of extremely high energy, typically from a ravenous black hole devouring matter at its core. So maybe Messier 83 wasn't empty at all. Maybe it's just very, very good at hiding. Among JWST's readings, one signal stood out: light from ionized neon gas only generated when immense energy wakes it up. Supernovae can be powerful, but not powerful enough for this. Only one thing can produce that kind of light: an active galactic nucleus, aka a black hole at work. So, the black hole in M83 might be playing an elaborate game of cosmic hide-and-seek. It may not glow brightly because dust is cloaking it, but thanks to instruments like JWST, it's still leaving behind light bite marks from its feeding habits. Moonlit battlefield reenactment with conformation, glowing arrows ready to fire. This discovery has caused scientists to reevaluate many of their assumptions. Maybe Messier 83 isn't the only galaxy hiding its black hole behind a dusty veil. One such misleading case, the mysterious black hole LEAD 568, a cosmic object that once stunned the scientific community. LEAD 568, a 40x overeater. When JWST first spotted LEAD 560, the black hole that existed just 1.5 billion years after the Big Bang, it appeared to be breaking all the rules. Early calculations showed it was devouring matter at over 40 times the Eddington limit, a strict natural cap on how fast black holes can feed. If true, this would make LEAD 568 one of the fastest growing black holes in the early universe, growing at a seemingly impossible pace. Scientists were baffled. But then came a new study, published in April 2025, that flipped the script. As it turned out, cosmic dust had pulled off another trick. The dust clouds around LEAD 568 had scattered and blocked light in a way that made it look like the black hole was eating far more than it actually was. Using infrared light, which isn't as easily blocked by dust, scientists recalculated its true mass. Nearly 1 billion times the mass of our Sun, 40 times larger than previous estimates. And with that corrected size, its feeding rate fell perfectly in line with the Eddington limit. LEAD 568 wasn't breaking the rules, it just looked like it was, thanks to an optical illusion of cosmic proportions. A lesson in dust and light. This revelation was a wake-up call. Cosmic dust can fool even the best minds. If we don't correct for it, we risk miscalculating black hole mass, feeding rates, and energy output. There are likely many more distant black holes that we've misunderstood thanks to this cosmic sleight of hand. And then, the little red dots. But JWST wasn't done. As it peered deeper into the early universe, it found something never seen before, a new class of tiny, glowing red galaxies dubbed little red dots. These galaxies were tiny, just 2% the size of the Milky Way, but incredibly bright and mysterious. Some might be densely packed with stars. Others might harbor supermassive black holes that outweigh the entire galaxy. Part 2: The Little Red Dots and the Silent Giants. The universe was once absolute darkness. Then, light erupted from the first stars, and the earliest galaxies took form. But if you look closely at the deepest images from the James Webb Space Telescope JWST, you'll notice something peculiar: tiny red dots, barely distinguishable among the sea of glowing lights. Scientists call them the little red dots. At first glance, they seem unremarkable. But upon deeper analysis, astronomers discovered something that challenged long-standing theories. These little red dots may be hiding supermassive black holes nearly as massive as the galaxies themselves. A universe of impossibilities. In a typical galaxy like our Milky Way, the central supermassive black hole makes up only about 0.1% of the galaxy's total mass. It's like a pebble in the heart of a vast desert. But in the little red dots, this balance breaks down. But in the little red dots, this balance breaks down. How can this be? How can a black hole dominate such a small space? To competing theories. To explain this strange phenomenon, scientists propose two possibilities. 1. Overcrowded star systems. The little red dots may contain a staggering number of stars up to 100 billion, like the Milky Way, but all crammed into a compact space. Imagine the entire population of a megacity like Tokyo packed into a broom closet. In such a galaxy, the night sky would never go dark. Stars would crowd every inch of view. 2. A galaxy defined by its black hole. Alternatively, each little red dot may only have a modest number of stars, but host a supermassive black hole that constitutes the bulk of its mass. In this case, the black hole isn't just the center of the galaxy, it is the galaxy. Clues from swirling light. Even if we can't directly observe these black holes, astronomers can detect their footprints by observing how gas and dust swirl around an invisible center at extremely high speeds. As the gas spins, it emits a unique light, typically ionized emissions from elements like neon, oxygen, or hydrogen, signaling a massive object feeding at the core. And JWST detected precisely that in many of the little red dots. The gas was not only swirling but glowing unusually bright, just as it would if it were being consumed by a black hole. But something stranger still emerged. No X-rays, no bright flares, just silence. Normally, accreting black holes emit strong X-rays. That's how we discover them in distant galaxies. Behemoths like the black holes at the center of Messier 87 or Sagittarius * in our own Milky Way blaze brightly in X-ray wavelengths. But the black holes in these little red dots, completely silent. Even with specialized telescopes aimed directly at them, scientists could not detect a single X-ray signal. It's as if these giants are turning off the lights and hiding in the dark. Could this be an entirely new class of black holes? The case for a silent black hole. There are a few possible explanations for why these black holes remain undetectable in X-rays. They may not be consuming enough matter to emit high-energy light. They're in a kind of hibernation. Their emitted X-rays could be completely absorbed by ultra-thick dust clouds. Or they might be emitting energy in a way we haven't yet learned to measure. if that last option is true. It could open the door to an entirely new branch of physics governing how black holes behave. What if some black holes don't need to glow to exist? What if they follow rules we've never seen before? Lessons in infrared light. Scientists now understand that light, especially visible light, has limitations. It can be blocked, scattered, or distorted by dust. That's why James Webb, with its ability to see in infrared, has become the ultimate tool in this game of cosmic hide-and-seek. The little red dots only appeared during a brief window in cosmic history when the universe was about 1 billion years old, and may hold the missing link in how galaxies and black holes evolved together. Why does it matter? Because if the little red dots truly host overmassive black holes, and if they represent a crucial stage in galactic development, then much of our current understanding about galaxy formation needs to be rewritten. These tiny, quiet dots may have been the first seeds from which today's massive galaxies grew. The silent giants inside them, once invisible, could be the architects of the universe as we know it. A game of cosmic hide-and-seek. From Messier 83 to Lead 568, and now to hundreds of distant little red dots, one truth is becoming increasingly clear: black holes aren't always raging monsters. Sometimes, they're quiet, cunning, and know how to hide behind layers of dust, missing light, and utter silence. And the James Webb Space Telescope, with its deep red ice, may be the best player in this grandest game of hide-and-seek the cosmos has ever known.